Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we are going to learn how to calculate linear attenuation coefficient using PHITS. I will explain the code and also how to analyze the result. Before that, we will learn a little bit about the theory. This is a slide of attenuation of gamma rays from Professor Dr. Fuad A. Majid. I will give you the link of this slide. You can find it online. When you make the simulation, just for calculate the attenuation coefficient, it's very simple. You just need to make a sample, the sample that you want to find the attenuation coefficient, and the beam. We will use photon. In here, we will use this formula to calculate the attenuation coefficient. And we can also make the slope if you want. Let's go to our code. What we usually change is the energy that you use, since the attenuation coefficient is related to the energy of the photon, the thickness. Maybe you want to change the thickness, but attenuation coefficient is a coefficient, it's a constant. No matter the thickness, no matter how you change the thickness, it's supposed to be the same. But we must be careful. Later we will know why we must be careful. In here, density, if you want to change the material, I will make it really simple. In here, next, NEGS is equal to -1. It means we want to transfer the photon only. If you change the NEGS equal to 1, not -1, I try, and the result is closer and it's better to -1. If you choose 1, you will also transport the positron and electron. It's also cost more time. This is the wait a minute. This is the material. This is the photon. This is energy. You can change the energy in here. It will automatically change. The material that you want to find the attenuation for this example, I will use lead. The surface, it's a simple one. It's a cylinder. This is our setup. We will see the three dimension. In three dimension, you can see this is just a slab of our material. A cylinder with the radius of 5 centimeter and the thickness of 2 centimeter. Is quite simple. And again, if you want to find the attenuation coefficient, just make your setup as simple as possible. We go back in here. For the first tally, I use T-track for see the particle distribution because it's important to understand how our simulation works. And the intensity in here, I use mass RRZ because our geometry is a cylinder. It's very suitable if you are using RZ. And our beam is also cylinders. It's really good. And it's very easy to set up. I use the diameter, not the diameter, but the radius of measurement is 0.5. So we will calculate a very narrow area. The number of z and z, it doesn't matter, but I use the height value because for me it doesn't matter. The calculation is also fast. It's less than 5 seconds. You can also use 100 or just 10 is also fine. Z minimum it's 0 because our material geometry start at 0 and the Z max is C2. C2 is the thickness that we set earlier. Photon, the particle is photon, and the energy in here we set minus from C1 is our energy that we choose for photon. And you notice here there's negative 0.001 and positive 0.001. So we want to calculate the intensity of this energy. So 0.001 is actually the tolerance, the uncertainty. That's what it actually does. The axis is z. So that's it. We can just run our simulation. Run. That's it. We see in here first track XZ. I want to see how it looks like. This is our setup. This is the material, the photon, and this is the distribution of our simulation, the distribution of particle of our simulation. Later, we'll find why look at this picture is important. But after that, we will see this is the intensity. I only measure the intensity inside the material. So I don't care after the material, outside the material. The material start at 0 and end at 2 centimeters. So I just care the intensity in that area. In here is the intensity 0. Okay. You must pay attention. In here is the intensity 0 and we will use it as for calculation. We will see the value in here, intensity out. As you can see, when you scroll, there are so many numbers. You can find this value and you can copy all of this. Oops. Open your favorite Excel or spreadsheet. I am a biggest fan of spreadsheet. So I will open this, paste, split text as column, 2 column. And then this one is basically the pin. We only use the first one, or you can use the second one. It's better to use the first one. We can delete this one. This one is the error, the statistical uncertainty, and this one the intensity. Move. Now we have this kind of things. I will change it to number so it's easier to read. You can see this value. And then we will calculate the linear attenuation coefficient using this formula. Okay. For in 0, we cannot calculate the attenuation coefficient because it's 0. It's the intensity. You see, intensity is 0, so it's none. We cannot calculate. But for here, we can use 1 over x times natural logarithm of this divided by I0. This is I0 and it's constant. It means we need to put a dollar sign in here. Like this in P2, dollar sign, dollar sign. Close, enter, or we can, before that, we can add negative. And then we have it. To make it easier to read, we change the format to a regular number. This is the value of attenuation of lead for the energy of one mega electron volt. There are a lot of number. So what we can do is take the average. And then this is the average and this is the value. Understand? Okay. Very easy, very fast, but you need to pay attention. Let's say we want to calculate this value. Wait a minute. Lead for 100 kilo electron volt. Let's do it. It's easy. Just change to, this is the energy is in mega electron volt. Let's change it to 1.0. It means it's 100 kilo electron volt. Run it. If you want to run it faster, you can do like this. It means it will use more CPU, and you can see it will run faster. Very fast. Okay, let's jump to the intensity. Do the exact same thing. maybe if you are really detailed, you already see that the error is zero in here and the intensity in here is zero. So you must raise suspicion with your result. And then just take the intensity and paste here. Okay, nice. First things that you must raise a question or a suspicion is in here. Why it's error? It means one of them is zero. Yes, it is zero. Why it's error in here? Because in here we have error also. And yeah, pretty much something happened. Why? And then you need to see again in here. In Monte Carlo simulation, in general, a result is you can use the result if the result, the uncertainty is below 10%. The statistical uncertainty is below 10%. If it's over 10%, you don't use it. The better one, it's less than 5%. In here, after 10, not 10, but 0.1, the statistical uncertainty is unreliable. So we cannot use it after 10. After here, we cannot use it. Okay? In here, it's already, you see, more than 10%. We cannot use it. And we must compare with our real. It's 559.7. The real value is 59.7. If we take the average value of this until this, okay, the result is still makes sense. It's 61. 61. From here to here, it's 61. It still makes sense. But if you take the average value from here to here, it will not make sense. It's getting 61,771. It's getting higher. We cannot use it. It's not reliable. Why? Because the error. Because of this, if you want, there are many options. First, the easiest one, just take the average value of this one because first it's true. Second, the statistical error is suitable. It's fine. There's nothing wrong with that. Second, if you want to take more, you need to add more history. You increase max cache or max batch. It doesn't matter. But you need to increase it. But why? Not necessary. It's not necessary. And the more important things is to know why this is happen. Why this is happen. Like why it's zero. This is why it's important to make this kind of visualization. You see, the lead is very good to stop the photon with energy of 100 kiloelectron volt. It means after in here, let's say around 1.1, 0.1 centimeter, there is no photon. If there is no photon, it means we cannot calculate. The intensity is zero already. We cannot calculate after that. That's why when we have the value of zero is not error or anything, because in reality, this is the physics. This is what happened in reality. The photon is just stopped right there. Okay, that's why it's really important to make this kind of things. But for another material, it's fine. And I will also give you this spreadsheet because why I check for carbon. And here you can see carbon, aluminum, iron, copper, lead for all of this value. And I also check if I use neg and EGS for one, positive one, and negative one. So you don't have to. You can check this is the attenuation coefficient. And if you want to, okay, let's say I want to find the slope. I already make the slope for you. You can see this is the slope. This is slope. You can check all. That's it. That's how you calculate the linear attenuation coefficient in PHITS. If you have any question, you can just ask me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.